Hello children, let us solve few questions based on what we have studied so far in this chapter. First question, a man moves on a straight horizontal road with a block of mass 2 kg in hand. If he covers a distance of 40 meter with an acceleration of 0.5 meter per second square, find the work done by the man on the block during the motion. Suppose man and block both are moving in forward direction. Their acceleration is 0.5 meter per second square. So due to this acceleration, a force will be applied on the block in forward direction. Its magnitude is given as mass into acceleration, and that is 1 Newton. Block is getting displaced by 40 meter in the direction of applied force. So applied force and displacement both are in same direction. So work done on the block will be force into displacement, and that is 40 joule. Second question, a force F is equal to 10 plus 0.5x acts on a particle in x direction, where F is in Newton and x in meter. Find the work done by this force during a displacement from x is equal to 0 to x is equal to 2 meter. We know that dw is equal to f dot dx. If we integrate both the sides, we get integration of dw is equal to integration of f dot dx. Here f is a function of x. So we can say w is equal to integration of 10 plus 0.5x dx from x is equal to 0 to x is equal to 2. And that comes out to be equal to 21 joule. Third question, the two blocks in an Atwood machine have masses 2 kg and 3 kg. Find the work done by the gravity during the 4th second after the system is released from rest. This is simple Atwood machine in which this is ideal pulley and this is massless string. The string passes over the pulley. Two ends of the string are connected with masses. In this case, M1 is 2 kg and M2 is 3 kg. System is at rest now. When it is released from rest, this being lighter mass goes up and this being heavier mass goes down. Suppose acceleration of these two blocks is given by A and tension in the string is T. So we can write equation of motion of these two blocks. For this block, equation of motion will be M1A is equal to T minus M1G. And for this block, equation of motion will be M2A is equal to M2G minus T. We can solve these two equations for A and T. A is equal to G by 5 and T is equal to 12G by 5. Next, we will calculate potential energy of two block system at rest. Suppose this is reference line. So potential energy of this block will be 0 and potential energy of this block will be given by M into G into minus H. Since this block is below the reference line, so we will take H as negative. So potential energy of two block system at rest will be minus 3gh. Let's say this is equation number 3. Next, we will calculate displacement of any of these two blocks in 4th second. And that will be given by displacement of any block in 4 seconds minus displacement of same block in 3 seconds. Let's say displacement of this block in 4 seconds is given by S4. So S4 is equal to ut plus half at square. Initially block was at rest, so u is equal to 0. A is equal to g by 5 and t is equal to 4. So S4 is equal to 8g by 5. And displacement of the same block in 3 seconds is given by S3. So S3 is equal to 9g by 10. So displacement of this block in 4th second will be S4 minus S3 and that is 7g by 10. Let's say this is delta S. So delta S is equal to 7g by 10. Delta S is equal to 7g by 10. So 2 kg block will be displaced upwards by 7g by 10 in 4 seconds and 3 kg block will be displaced downwards by 7g by 10 in 4 seconds. So potential energy of the system in 4 seconds will be m1g into delta S plus m2g into minus h minus delta S. Put the value of delta S is equal to 7g by 10. So PE2 is equal to minus 7g square by 10 minus 3gh. So change in potential energy of two block system is equal to delta P is equal to PE2 minus PE1. PE2 is equal to minus 7g square by 10 minus 3gh, and PE1 is equal to minus 3gh. So minus 3gh plus 3gh will get cancelled. So delta PE is equal to minus 7g square by 10. Take the value of g as 9.8. So delta PE is equal to minus 67.23 joule. So work done by the gravity will be equal to negative of change in potential energy, and that is equal to 67.23 joule. Fourth question, figure below shows a spring fixed at the bottom end of an incline of inclination 37 degree. A small block of mass 2 kg starts slipping down the incline from a point 4.8 meter away from the spring. The block compresses the spring by 20 centimeter, stops momentarily, and then rebounds through a distance of 1 meter up the incline. Find the friction coefficient between the plane and the block, the spring constant of the spring. Take G is equal to 10 meter per second square. This is the figure given. We will consider two cases here, when the block moves down the plane and when the block moves up the plane. When the block moves down the plane, this is FBD of the block. mg is its weight which works vertically downwards. Its component along the plane will be mg sine 37 degree, and perpendicular to the plane will be mg cos 37 degree. N is the normal reaction applied by the plane. Since the block is moving downwards, so friction force on it will work up the plane, and it is given by mu n, where n is equal to mg cos 37 degree. Net force on the block downwards will be mg sine 37 minus mu n. So F net is equal to mg sine 37 minus mu n is equal to mg cos 37. So it is mg into sine 37 minus mu cos 37. Value of m is given as 2 kg. G we can take 10 meter per second square. Value of sine 37 is 3 by 5, and value of cos 37 is 4 by 5. So F net is equal to 4 into 3 minus 4 mu. This is equation number 1. Work done by this force will be given by force into displacement in the direction of force. We will calculate displacement. Initially, block is 4.8 meter away from the spring, and it compresses the spring by 20 centimeter, that is 0.2 meter. So total displacement of the block will be 4.8 meter plus 0.2 meter, and that is 5 meter. So work done will be equal to 20 into 3 minus 4 mu. This is equation number 2. Now this work done will be stored as spring's potential energy, and that is given by 1 by 2 kx square, where x is amount of compression and k is spring constant. So k is equal to 1000 into 3 minus 4 mu. This is equation number 3. When the block moves up the plane, this is FBD of the block. mg is its weight that works vertically downwards. Its component along the plane is mg sine 37, and perpendicular to the plane is mg cos 37. N is the normal reaction applied by the plane. Since block is moving up the plane, so friction force on it will work down the plane, and it is shown by mu n, where n is equal to mg cos 37. So net force on the block will be downwards, and it is given by mg sine 37 plus mu n, where n is equal to mg cos 37. Putting the values of m, g, sine 37 and cos 37, we get F net dash is equal to 4 into 3 plus 4 mu. This is equation number 4. Since the spring is compressed, so it will push the block up the plane by equal and opposite force to F net dash. So force applied by the spring will be up the plane, and its magnitude will be equal to F net dash. So work done by this force on the block will be F net dash into displacement of the block up the plane, and it is given as 1 meter. So W2 is equal to 4 into 3 plus 4 mu. This is equation number 5. Now work done by these forces F net and F net dash will be equal. So we can equate equation number 2 and equation number 5 to get the value of mu as 1 by 2. Now we can put the value of mu in equation number 3 to get the value of k is equal to 1000 Newton per meter. In next video, we will start circular motion. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.